Okay, this is a lesson on solving quadratic equations by completing the square, and this is going to be our third method that we've learned for solving quadratic equations. We've learned to solve some quadratic equations by using factoring and the zero products property. We've also learned to solve some quadratic equations by the square root property, and now we're learning a method that is actually more versatile. It'll be able to solve all quadratic equations. But before we can learn this method, we have to understand what the concept of completing the square means, and this means to add a third term constant to a quadratic binomial, such as if I have x squared plus 12x, x squared, the squared term is what makes it a quadratic polynomial. It's got two terms. The other term, in terms of employing this method of completing the square, has to be an x term. So what we're going to add to this quadratic binomial is a third term such that it would create a perfect square trinomial, also known as a trinomial square. The way that we do this is we will take we're going to take half of 12 and we're going to square it and add it to the quadratic binomial. So half of 12 and square it. So half of 12 is 6, so 6 squared is 36. So what we're going to add is 36 to complete the square. By adding 36, we've created a trinomial square. And that's known as completing the square. And the reason we do that is because, as we talked about in class yesterday, that a trinomial square always factors to a binomial squared. So we're going to get some more practice at completing the square now, before we talk about how we use that to solve quadratic equations. So looking at this one, x squared minus 6x, what I'm going to do is to complete the square, I'm going to say 1/2 times, let me write that better, times -6, and I'm going to want to square all that. So half of -6 is -3, so what I will get, -3 squared is 9, so it completes the square. It's always going to be a positive number that completes the square, so I'll complete the square with plus 9. So to complete the square on the next one, I'm going to take half of 5 this time, and work with fractions, don't work with decimals when you do this. So I'm going to take half of 5 here, and I'll square that. And half of 5 is, we'll call that 5/2, and 5/2 squared is 25/4. So it's plus 25/4 that completes the square for that one. Okay, so the next one is x squared minus 20x. So I'll want to take 1/2 of -20. And square that, so that's going to be, so half of -20 is -10, so -10 squared is plus 100, completes the square there. And then the next one, let's look up here. We'll have x plus 3/4 x, so I'm going to take, it's a little trickier now, I'm going to take 1/2 times, let's just use parentheses here, stay consistent. So half of 3 fourths and square it. So half of 3 fourths is 3/8. 3/8 squared is 9/64. So actually let's make that, put that in green. So plus 9/64 completes the square there. Next one I have minus 4/3 x. So I'm going to take half of having trouble there. So 1/2 times -4/3 and square that. So half of -4/3 is -4/6, so that's actually -2/3. So -2/3 squared is 4/9. So I'm going to add 4/9. Again, when I complete the square, it's always positive. So add 4/9 right there to complete the square. And the last one I have here is, and when you have a minus x, that means -1. So I'm going to take half of -1 and square it. So that would be -1/2. So that would be positive 1/4. Completes the square there. Let me write that a little bit better. Okay, so that's a little practice of completing the square. Now let's see how we actually use this to solve quadratic equations. And so we learn to complete the square because it's the key step we use when solving quadratic equations using the complete the square method. So this is actually an equation we could solve by factoring, but just to learn the new method, we're going to solve it by completing the square. So instead of factoring, factors of 12 that sum to -8, we're actually going to subtract 12 from both sides. You'll see why I'm doing this. It'll seem like I'm doing the reverse of what I need to do, but that's going to get me x squared minus 8x equals 0. Now you'll notice, not equals 0, equals -12. So you'll notice I leave a little space there. That's where I'm going to put the, actually I'll do it on the next line. But so I'm going to want to put in right here the number that completes the square for this quadratic binomial, turning it into a trinomial square. So I'm going to want to take half times -8, and I'll square that. So half of -8 is -4 square that, so it's plus 16. So completing the square, now I'm ready to fill in, so I'm going to add 16 to complete the square. Now remember, this is an equation. I can't just add it to one side without adding it to the other. So I will have plus 16 there as well. So the next thing I want to do is do a little simplifying. Actually, I'm going to go ahead and factor this left side. I've created a trinomial square now. Remember, trinomial squares factor to a binomial squared. Go ahead and do the arithmetic on the other side. -12 plus 16 is 4. Now I can solve this using the square root property. So x minus 4 equals plus or minus the square root of 4. So that means x minus 4 equals plus or minus 2. Then I'll add 4 to both sides. And I'll get that x equals positive 2 plus 4, which is 6, or negative 2 plus 4, which is 2. So let's see if both of those solutions work. So I'm going to check those right here. I'm first going to try 6, the original equation. 6 squared minus 8 times 6 plus 12. Does that equal 0? Well, that's going to be 36 minus 48, so that's negative 12 plus 12. So it does work. You get 0 equals 0, so that checks, and then we'll try 2. 2 squared minus 8 times 2 plus 12. Does that equal 0? Well, I'm getting 4 minus 16 is negative 12 plus 12 is also 0. So I'll say 0 equals 0. That checks, and I can circle those as my solutions. Okay, so next one we're going to solve is x squared equals 4x plus 3 by completing the square. And so first thing I'm going to do with this one is I'm going to subtract 4x from both sides. And I'll have x squared minus 4x equals 3. So now I want to complete the square there, so I'm going to say 1 half times, let's just do it like this, times negative 4, and I'm going to square all that. So that will be, so half of negative 4 is negative 2, negative 2 squared is 4. So I'm going to add 4 to both sides. So I have x squared minus 4x plus 4 equals 3 plus 4. So that's going to get me x minus 2, the quantity squared, equals 7. Use the square root property. That'll be x minus 2 equals plus or minus root 7. And I'm going to add 2, and I'll have my two possible solutions of x equals 2 plus or minus root 7. So I'm going to have to check both of those, and I'll go through that with this one to show you this by the next one I'm going to use the calculator, but this one I'll use by plugging in the actual solutions and working them out. So I'm going to say 2 plus root 7 squared. Does that equal 4 times 2 plus root 7 plus 3? So remember, we've got to square a binomial here, so this will be 4 plus 2 times root 7 be 4 root 7, plus root 7 squared will be 7, so that'll be 11 plus 4 root 7. And again, does that equal, this would be 8 plus 4 root 7 plus 3, so that would also equal 11 plus 4 root 7, so that checks. Then try the other one. 2 minus root 7 squared, does that equal 4 times 2 minus root 7 plus 3? And this will be 2 minus 4 root 7, and then that'll be plus, I'm sorry, that won't be a 4, that'll be a 2, that'll be a 4. That'll be 4 minus 4 root 7 plus 7. And here I'll get 8 minus 4 root 7 plus 3. And again, I get 11 minus 4 root 7. By the way, I got to sneak a question mark in there. 11 minus 4 root 7. So that checks, so those are good solutions. Now let's move this up and solve this one. I've got 4x squared equals 2 minus 7x. So on this one, I'm going to bring the 7x over. And I'll have 4x squared plus 7x equals 2. Now, I can't complete the square or very easily when I don't have a lead coefficient of 1. So I'm going to multiply both sides by 1/4 here before I complete the square. And I'll have x squared plus 7/4 x equals 1/2, and I'm going to have 1/2 of 7/4, and I'm going to square that, and that's going to equal 7a squared, which would be 49/64. And so that's what I'll add in there to both sides. And I'm going to make 1/2 32/64 plus 49/64, and that will get me factoring of x plus 7a. The quantity squared equals, that equals 81/64. And so let's go up here. That will get me x plus 7a equals positive or negative 9a. All right. So then I'm going to subtract 7a from both sides, and I'll get x equals, so that's 9 minus 7/8 would be 9 minus 7, that would be 2a, or 1/4, or and then I've got -9 minus 7, or -2. Actually, these are pretty easy to check, so I'm going to check these without using my calculator. So I'm going to go with 4 times 1/4 squared. Does that equal 2 minus 7 times 1/4? Whoops. So this is 4 times 1/16, so that's equal to 1/4, and this is 2, or 8/4 minus 7/4, so that also equals 1/4, so that checks. So let's check the other one. Then I'm going to check -2. 4 times -2. Squared, does that equal 2 minus 7 times -2? And so that's 4 times 4, or 16. This is 2 plus 14 over here, so that's 16. And so that does check out. So that confirms those solutions. Last two problems. So I've got to solve this by completing the square. So I'm going to start by distributing and make that x squared plus x equals 20. So to complete the square, since my coefficient here is a 1, I'm going to take half of 1 and square it. So half of 1 and square it. So that'd be 1/4. So that's x squared plus x plus 1/4. Don't forget to add it to both sides. And that's going to be, I'm going to make 20/84 plus 1/4. And so I factor this is x plus 1/2 the quantity squared. 84 plus 1/4 is 81/4. I'm going to use the square root property and say this is x plus 1/2 equals plus or minus the square root of 81/4. And so I get x plus 1/2 equals plus or minus 9/2. Subtract 1/2 from both sides. And I get x equals 9/2 minus 1/2, which is 8/2 or 2. And I get, the other one I get is negative 9/2 minus 1/2, so that's negative 10/2 or negative 5. Let's check that real quick. Check those. 2 times 2 plus 1. That actually doesn't seem to be working. So let me check my work here real quick. Sorry, I realized this should actually be a 4. So it's 4 negative 5, because you get 9/2 minus 1/2 is 8/2, so that's 4, not 2. So I'm going to check that again. Check kept me from putting a wrong solution down. That's a good thing. So let's go 4 times 4 plus 1. Does that equal 20? And it does. Now let's try negative 5. Negative 5 times negative 5 plus 1. Does that also equal 20? Well, that's negative 5 times negative 4. And that does equal positive 20. So 20 equals 20. So those are good solutions. All right, so let's move this up a little bit and do this last problem. I'm going to go ahead. I've got 3 times this. I'm going to need to get a lead coefficient of 1. Let's go ahead and distribute. I think you have your choice here of getting rid of the 3 right away or going ahead and distributing, but I think I'm going to go ahead and distribute. Minus 3 equals 5x. So I don't want to try to move things around until I get rid of the parentheses. So I'm going to add 3 to both sides, get that over there, and I'll get 9x squared equals 5x plus 3. Get the 5x over here. And I've got 9x squared minus 5x equals 3. Now I need to get rid of this 9. So I'm going to multiply both sides by 1/9 to get rid of this 9. I need to have a lead coefficient of 1 in order to complete the square. So this is going to be x squared minus 5/9x equals 1/3. So to complete the square, I am going to take half of negative 5/9 and square it. Don't need those parentheses. So I'm going to square. I need parentheses like that. Okay. So anyways, I get negative 5/18. So remember that 18 squared is 324. So I'm going to get 25 3/24 is what I'm going to get. So 25 3/24. And so that's what I'll add to both sides. Now, I've got to get 1/3 with a denominator of 3/24, so I've got to think about that for a second. Okay, so that's, so since I had 1/3 on that side, that 1/3, so I'm looking at this 1/3 right here. So I've got 1/3 is 108 3/24, and then plus I've got to add the 25 3/24. And so go ahead and factor here, x minus 5/18 quantity squared equals 13, and 1 is 3, and so it looks like I've got 133 over 3/24. So then I'm going to use the square root property and make that x minus 5/18 equals the positive or negative square root of 133 3/24. 3/24 is a perfect square. 133 is, I've checked to see if I could simplify that, but I can't, so it's plus or minus root 133 over the square root of 3/24, which is 18. So I'm going to add 5/18 to both sides, add 5/18 to both sides, and I get x equals 5/8. I want to keep everything over 18. 5 plus or minus root 133 over 18. Now, I'm definitely going to use my calculator here, and I will do that while I have the tape off, and I'll show you what that equals, but let me get my calculator. So now I'm going to do my check over here, and I'll use my calculator as help. So I've got 3 times, this is where I'm going to sub in my first value, which is 5 plus, this is really messy here, root 133 over 18, all that's squared. No, that's not squared, just minus 2. It would be squared if I had distributed. And actually, no, that's right. Oh, no, that is squared. Okay, so that is squared minus, let me just start that one over a little bit. So it's 3 times 3x squared minus 1 does that equal 5 times all of that. So this is why I really need our calculator for help on something like this. Now, I'm going to use the left side. I'm going to use the left side for help first, just since that's a little easier to calculate. So I'm going to say 5 times memory recall on my calculator, and that equals, got that on the right side, that equals, we're going to call that 4.59. Let's see if we can get the other side to work. And when I tried all that on the other side, I got 4.59. So let's see what happens when we do it with the other side. So that checks out. So the other check is 3 times the quantity, 3 times the quantity 5 minus root 133 over 18, all of that squared minus 1, and we want to see if all of that equals 5 times 5 minus root 133 over 18. So let's check that out and then we'll be done with the lesson. So when I use my calculator, I got that both sides equal to approximately negative 1.814. So that makes it check up. And so we are going to consider these two solutions right here are correct solutions for that equation. And that is the end of the lesson.